Dalton's law relates the pressures of multiple gases, so a mixture of gases in the same container. Let's take a look. First of all, a partial pressure is just the pressure that a gas would have or it would exert if it were by itself, if it were alone in a container. So we often have mixtures of gases instead of just one isolated gas. The air, for example, is a mixture of mainly nitrogen and oxygen. So the oxygen and the nitrogen would each have a partial pressure, which contributes to the overall total pressure in, say, the room. So for a mixture of gases, the total pressure is just the sum of the partial pressures. It's pretty simple. Here is a picture of what we mean. So if I have a mixture of hydrogen and helium, when I'm thinking about the partial pressures, my hydrogen will have its own partial pressure, helium will have one, and then we would just combine them by adding them together. That's how we would find the total pressure. Here's the equation, and we're only going to work with this top one, so don't worry about this bottom one. P total is just the sum of all the partial pressures, and it only applies to a mixture of gases. If a gas is by itself, we cannot use this. So your quick summary is that the total pressure of a mixture of gases is equal to the sum of those partial pressures of each individual gas. Sample problem. We know that air contains oxygen, nitrogen, carbon dioxide, and a few other gases, so trace amounts of other gases. We want to know the partial pressure of oxygen at 101.3 kPa if the partial pressures of nitrogen, carbon dioxide, and other gases are given to us here. So we were told this piece of information, and I hope you can see that this would be our total pressure. This value is the pressure of nitrogen. This one, the pressure of carbon dioxide, and this one, the pressure of the other gases. We know that because it said respectively afterwards, so it's going to follow the same order that the gases were presented to us in the problem. Here's our formula. So P total is equal to the partial pressure of nitrogen plus the partial pressure of CO2 plus the other gases plus O2. Let's plug in what we know. We put the total in, which was 101.3 kPa. We had the value for nitrogen, for CO2, and for the other gases. So now we just need to solve for the partial pressure of oxygen. Remember that for addition and subtraction, we have to round our answer based on the number of decimal places, not based on the total number of significant figures. So we can simplify to 101.3 equals, and we added these values together, plus PO2, to find that the partial pressure of oxygen gas is 21.22 kPa, or 21.2 kPa when we factor in sig figs. And now y'all try. Pause the video and try this for yourself. Okay, let's see how you did. This is your setup. And so when you solve for the partial pressure of gas number 3, you should find it to be 576 millimeters of mercury.